Good evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to my latest video. Now, this video I'm going to call Tumbling Wall, and I call it a tumbling wall for a reason. The wall specifically referring to that persistent subtropical ridge, that southeast ridge that has definitely been the persistent main player of the weather for much of the January and specifically the February time period for the eastern US. So, right now, we're looking at a tumbling wall or a tumbling ridge in tonight's video, and I'll get more into those details on the latest weather forecasting model charts. All right, so let's get right into tonight's video. Now, the first thing I wanted to start with when we talk about things is I wanted to go over kind of where we've been the last 2 months, January and February of 2023. And if you are an Eastern winter weather lover, this winter has not been for you, obviously. So looking at January, these are the mean or average temperature anomalies over the month of January. And the maroons and these lighter brown colors indicate much above normal temperatures, warmer than normal. And then these blues and these greens out in the western US indicate below normal temperatures. So you can really see that big time division between just unusually warm temperatures on the order of 5 to 10 degrees Fahrenheit above normal for a large chunk of the Midwest, the New England area specifically, right on down into the Mid-Atlantic area. Florida was just 2 to 3 degrees Fahrenheit above normal for the month of January. And then here's the colder temperatures out west. And then over here on the right, I'm showing the mean temperature departures from normal. Generally looking at, again, very similar pattern where we have much above normal temperatures, generally east of the Mississippi River, all the way to the East Coast. And now February has been a little bit warmer for you folks living in Florida. We're talking 5 to 7 degrees Fahrenheit above normal temps for the Sunshine State for February. And that 7 to 8 to 9 degree Fahrenheit above normal range went all the way up from the southeastern U.S., Georgia, right up to the Carolinas and Virginia, also into Ohio. Many of you I've interacted with on social media, really wondering where in the world is winter this year. And, with these milder, much above normal temperatures, we just haven't seen much in the way of snowfall either. Now look at the contrast here in the western U.S. in the month of February. Much below normal in the green shading here. The scales over here on the right. We're talking 6 to 7 degrees Fahrenheit below normal temperatures in the green coloring. And then the purple coloring here in the higher elevations on the order of 11 degrees Fahrenheit below normal in February. So January and February have been much above normal, pretty much from the Midwest all the way to the East Coast. Now, what really has been the main synoptic players, the pressure systems that have impacted, that have resulted in this type of setup as far as temperature anomalies? The first thing is this ridge and trough couplet that we see on the left. We see that upper level ridge was pretty much established and didn't move very much at all. Pretty much stationary, in fact. We have this ridge axis, specifically in February, where the ridge axis set up all the way up into the Aleutian Islands of Alaska and also even as far west as the Bering Sea. Now, what that allowed to happen is a downstream trough of this anomalously higher height center or ridge. And so we have much below normal heights in the purple coloring here off the western coast of the United States. And so you get digging troughs, specifically into California in the month of February. And, that really resulted in some problems as far as flooding, as far as, just this incredible amount of snowfall in the Sierras. And, you guys are sitting really good now. You really needed a good winter to break out of this, that longer term drought you were experiencing, and you definitely got it this winter. So we had this persistent trough. We had the location of this upper level ridge, generally to the Aleutians, up into the Bering Sea at times, not really moving a whole lot, not moving to the east, So therefore, this pattern remains stagnant for weeks on end in the month of February. And then we move further east now, here with the graphic on the right, and now in the orange coloring, I'm showing anomalously above normal heights, which is associated with upper level ridging, which is associated with milder temperatures and dry conditions. We have seen some systems pass through from west to east across the U.S., but in general, we've seen some very mild conditions, specifically for January and February. This ridge, the tropical ridge, has just been in control. So generally, we had a subtropical ridge that's dominating the eastern U.S., and it resulted in what's known as a negative Pacific North American pattern, negative PNA, where we get the troughing in the western U.S. and the ridge downstream across the east. Now, let's talk and move right from the past to the present. Now, there's been some major changes that have occurred, specifically over the last couple weeks in the atmosphere. We start first with a discussion on the stratosphere. Now, this is the second layer of the atmosphere, and within the stratosphere during the winter season, we can see some major changes that occur, specifically with the temperatures of the stratosphere. This is a graphic from 18 February. This was the GFS model, 10 hectopascal level. So we're sitting, up around 60,000 feet above the ground. Notice this maroon or lighter coloring here and the white coloring. That's indicative of anomalously warming temperatures in the stratosphere at the 10 millibar level. These are the anomalies in degrees Celsius, and so well above normal temperatures in the stratosphere. Okay, so when you get these kind of sudden stratospheric warming events to occur, there's some after effects we have to take into account. So now the sudden stratospheric warming occurred in February, generally in that 15 to 18 February time period. And then 2 to 4 weeks after these type of events, you can actually get a reversal in the mean sea level pressure, as well as a reversal in the surface temperature anomalies here. Now these are in degrees Celsius. Anywhere from the event to 30 days after the event, 2 to 4 weeks. And so what you get after a anomalous warmth in the stratosphere as far as temperatures go, these sudden stratospheric warming events, you get higher mean sea level pressure over the Arctic, and you get lower mean sea level pressure generally in the mid-latitudes, specifically across the eastern U.S., stretching all the way across the North Atlantic on into Europe, into Eurasia. You just get this ring of blue shading beneath higher pressure or higher heights in the Arctic. Okay, and then the surface temperature anomaly here in degrees Celsius. Whenever you got the troughing and the lower heights, lower than normal heights, you typically get cooler than normal temperatures. And so across much of the United States, all the way 2 to 4 weeks after the sudden stratospheric warming, you could have below normal temperatures widespread across the mid latitudes, from the west coast of the U.S. to the east coast of the U.S., and then also across Europe and Eurasia. So this has changed the game a little bit. The sudden stratospheric warming, it was a major event which occurred in February of 2023, and these are from research conducted, these are the resultant mean sea level pressure anomalies and temperature anomalies after these events. Additionally, we have really, the Madden-Julian oscillation, the MJO, has really changed in the last couple of weeks. Now, this is the latest from today, the 1st of March, 2023. These are the latest forecasts. The European model on the left, the Jeffs V12 in the middle, and the CFS V2 on the far right. What do you notice about these three images? Well, they all pretty much are depicting the same thing to happen. Now, sure, we look at the European model and then the CFS V2, which are fairly close to each other. You see a stronger amplitude or magnitude of the phase 8 forecast for the MJO, the European as well as the CFS V2. Okay. Now the Jeffs V12 also shows fairly strong magnitude into phase 8 for the MJO, but it's not nearly as far to the left here on this curve, right? On the Jeffs V12 here in the middle. Bottom line though is consensus is there. Now, we flirted with MJO Phase 8 back in January. But one thing that you tend to realize over time by watching these patterns and trends is that MJO phase 8 is not really favorable to occur during La Nina winters. Well, guess what's happening now? La Nina is collapsing. We've had significant change of water temperature anomalies now in the eastern Pacific, equatorial area of the eastern Pacific, as well as that equatorial central Pacific area. And so these are this is the forecast here, the European. By the way, each of these lines here, generally showing you the dates. So, for example, let's just use a European example here on the left. So the forecast is for the MJO. Right now, we're at the 1st of March, so it's in phase 7. It's going to strengthen in amplitude or magnitude. Here's the 5th of March, and then it's going to cross over around the 6th of March. The European model says the MJO will cross into phase 8 around the 6th of March. And that just kind of rotates around well far away from the center of this small inner circle here. So we're going to expect some major impacts from this. And the Jeffs V12 has the MJO going to phase 8 around the 7th of March, so about a day later, but fairly close in timing. And also, all the way through the 15th of March, you see it in phase 8. And then the CFS V2 showing the MJO going to phase 8 right around just before the 8th of March and working its way, taking its time really all the way along the outer periphery of phase 8. And not even it goes briefly into phase 1 according to the CFS V2 around the 25th, the end of March, and then back into the null phase or neutral condition phase. So this is a significant change. We missed out on the phase 8 back in early January, and you scratch your head and you say, as a winter weather lover, that would have been awesome to see something like this back in January, right? But anyway, weather is what it is, and we really can't change or control it. So this is what we're faced with going now through the month of March. Now this is a colder phase to the MJO. Teleconnections are also starting to line up in a more constructive interference manner to where, here's an example. This is all the EPS, European Ensemble Prediction System. I got Arctic Oscillation forecast here in the upper left showing the AO going negative after the 4th of March, remaining negative all the way to the 13th of March. Then upper right here, I have the North Atlantic Oscillation, NAO, showing a negative. We have a negative trend. We have upper level ridging now across the North Atlantic. And that usually is also a impact or a post effect of that stratospheric warming we talked about. You typically get upper level ridging across the North Atlantic over towards Greenland. So we have a negative NAO, North Atlantic Oscillation, all the way until the 14th of March, per the latest forecast. And then the European East Pacific Oscillation. Now, we've seen this thing dive, the EPO, dive to the negative side quite sharply a couple previous times during the winter season this year. And usually when it dives like this to strongly negative, that indicates a pattern change to where we get colder air pushing further east. Now, if you look at the EPO forecast, it shows a negative mode of EPO now starting around the 5th of March and lasting all the way to the 16th of March. So about an 11-day period of a negative EPO. And then over here in the bottom right, the EPS forecast is calling for a negative PNA. Now this has been between the southeastern ridge and the negative Pacific North American pattern, the negative PNA. Those two have been the biggest winter weather villains if you want winter weather in the eastern U.S. And let me tell you, the snowfall departures are just astounding. I took a look at that before this video. I don't have it in here to share with you. But the latest Climate Prediction Center snowfall departures they tell everything you need to know about where the storm track was, where all the snow fell. It's so evident when you look at the snowfall departures for the meteorological winter, December to February. But bottom line here, teleconnections. AO negative, that indicates cold in the east. NAO negative, that ultimately will, depending on where that NAO is situated, if it's a west-based negative NAO, then it definitely favors higher heights to the west of Baffin Bay. And that favors cold temperatures. If we look at the EPO dropping sharply negative, cold temps in the east. If we look at the PNA, look at this thing. It starts off negative like it's been for almost all of February. And then it finally goes slightly positive after the 10th of March. Believe it or not, positive with the PNA. Let's continue. Now I want to delve into some of the 500 millibar upper air charts, the forecast. These are height anomalies in decameters. I'm sorry, height anomalies are in meters. The heights are in decameters. So bottom line here, let's take a look at the GFS ensemble system first here, the GEFs. The major feature, and I pointed this out in social media earlier, is that we had this back in December too. We had two very strong upper level ridges, one over the Northeast Pacific and one over the North Atlantic around Greenland back in December. And ultimately what happened is these two ridges merged over the top, similar to what they're forecast to do around the 7th of March. So you have one major ridge there west of Greenland, you have another major ridge extending from southwest to northeast, the ridge axis, and these two are merging. They're coalescing into one area of higher heights at the higher latitudes here. Now, what does that do for you? Okay, typically when you have these higher heights over the Arctic, over those polar areas, that is a result of that major sudden stratospheric warming event, okay, number one. And whenever you get the blocking these higher heights in this particular area of the world, you tend to get lower heights beneath it in the mid latitudes. So let's watch this trend as I go through the GFS ensemble forecasting system, the GEFS forecast. So here's 7 March on the left. Any orange coloring you see is associated with higher than normal heights. Any purples and greens are below normal heights. Now the white here is very much above normal heights, by the way. So we start on the 7th of March here, and look what we got going on here. You know, we have that persistent trough still off the western coast of the U.S. We have a very deep closed upper level low, almost looks like a 50-50 low situation, 50 degrees north, 50 degrees west longitude. And so we got some very cold temps over the North Atlantic associated with this deep closed upper level low. We still have milder temperatures across the southern U.S. as well as up to New England, the mid-Atlantic. You see this on the 7th? So really no pattern change at that point. The ridge bridge is at the top of each of these images. Now, look what happens here on the right for the 10th of March, according to GEFS. You still have that persistent ridge sitting here in the Pacific Northwest, and you still have this very deep closed upper level low in pretty much the identical position, the 50-50 low position. And then look what's happening here. You're starting to see cooler, well, I shouldn't say cooler because we're not looking at temperature anomalies. We start to see lowering of heights here along the New England coast down to the mid-Atlantic. See this? See the blue coloring here? We didn't see that over here on the 7th, did we? We're seeing it now starting to show up in the forecast for the 10th of March right here. See that? And look what happened over here at the top across the higher latitudes. Those ridges merged and we have anomalously above normal heights up there. Move it forward. All right, so now we're into a full pattern change here by the 12th of March. Look at the graphic here on the left. Greens and blues from west to east coast. See this? Now the greens indicate more anomalously lower than normal heights than the blues. But nonetheless, we got blue coloring, we got lower than normal heights. This is a typical post-major stratospheric warming effect. We have higher heights still lingering across, the polar areas, the Arctic area, and we got those lower heights overspreading much of the U.S. by the 12th of March, according to the GEFS model. This was the midday 12Z run. And the forecast here on the right from the GEFS, this is for the 15th of March, going to the morning of the 15th of March. And I mean, look at this. The blue coloring, the blue shading remains from the west coast to the east coast. A little bit more anomalously lower than normal heights there off the New England coast. Now that could be associated with some type of storm system. That could be a storm signal by the mid portion of the month of March. So that's something to keep an eye on. Now, as far as temperature anomalies go, if we look at the coloring here, if you see the maroon coloring and the brown coloring, that indicates above normal temperatures in degrees Celsius. And then the purple, that's the greatest departure from normal, below normal area. Purple, below normal temperatures. Greens, below normal temperatures as well. So initially on the 7th of March, what are we looking at? We're looking at that continuation of what looks like a ridge over the southern U.S. right up to the Midwest and also kind of spreading to the east there to the mid-Atlantic. Above normal temperatures coming up on Monday the 6th of March as well as Tuesday the 7th of March. Below normal temperatures over western Canada right on down to the western U.S. Same old song and dance, right? But then look over here on the right, the forecast. What happened? Now we're looking at Friday the 10th of March, Friday morning, and look, oh my, what happened? Where are all those above normal air temperatures at? They're down. They're down here now in the Gulf of Mexico. The pattern has changed. The lowering of the heights has occurred. The troughing has now established itself. And so you have very cold temperatures centered over the central U.S. by the 10th of March. We're talking Kansas, right up into Nebraska and the Dakotas and Montana. But you still have below normal temperatures in the Midwest or the East Coast by the 10th of March. Now, by the time we get to the 12th of March here on the left, the continuation of cold is widespread from coast to coast. Where's that ridge at? Where is it? You don't see it. It's gone. It's down over Mexico at this point, the Yucatan. All right. And then over here on the right, look at this. Look at these green colors going all the way into the Midwest, even over parts of the Mid-Atlantic by the 15th of March. So this doesn't look like it's going to be like a 24 to 36 hour cold shot and then it pulls out of here. This looks like it's a little bit more longer in duration, a type cold event that's coming for March. Now the European ensemble forecast, now we're going back to the 500 millibar heights analysis here and the anomalies. And initially on the 7th of March here on the left, look how dominant this 588 decameter ridge is sitting over Yucatan. It used to be situated over the western Atlantic here, but now it's basically retrograded or retrogressed to the southwest over Yucatan, the center of it. 588 decameter upper level high, and then you've got the ridging going all the way up from Texas to New England on the 7th of March. The coldest or the lowest heights remain over the Pacific Northwest. And you got the ridge bridge again here on the EPS ensemble forecast. So no matter how you cut it, both models are in really good agreement for this time period. Forecast of the EPS here on the right, showing much below normal heights here across the North Atlantic. And to the north of that, or the northwest of that, you have a much above normal heights over the higher latitudes. And now look, what happened? Where's that orange, light orange coloring anymore? You see it? I don't. That means we have much lower heights now, stretching from the Rocky Mountains right to the central U.S. and now working its way east towards the East Coast. So you see that? Keep going here. European ensemble forecast, graphic on the left here showing the forecast for Sunday the 12th of March. And whoa, look at this thing. Look at how green this color is. That's indicating 180 to 210 decameter heights below normal based on climatology. All right. So we have below normal heights in the green. Those are the greatest extremes in the below normal heights. We still got the upper level higher heights there up towards Alaska, even north of Alaska up to the Arctic. And so we got this effect, this post-sudden stratospheric warming effect where the lower heights beneath higher heights. And then over here on the right, the forecast for the 15th of March, and it's still locked in here, okay? The lower the normal heights, the troughing, well established over the Midwest to the East Coast at this point, specifically the Mid-Atlantic. And then, you still got some pretty below normal heights there across the North Atlantic again. Keep moving. All right, European ensemble prediction system temperature anomalies over here on the left, very much in agreement with the Jeffs, showing above normal temperatures stretching from Texas on up to the Ohio Valley. By the 7th of March, the coldest temperatures in the purple and green colorings out here out west, Western Canada and the Western U.S. By the time we move ahead to the 10th of March over here on the right, look at this purple color. This is starting to look Barney-ish. All right, starting to look a little more like Barney the dinosaur again. We have the core of the coldest air across Nevada, Utah, Colorado. Boy, you had a good ski season in Colorado, haven't you? And now look at the temperatures are really the temperatures here are taking a pretty good plunge across Texas Panhandle at this point, and Kansas and Nebraska and the Dakotas. And the lighter blue coloring here on the East Coast. What happened to this? What happened to this? Where's the orange coloring? Where those above normal anomalies are gone. That subtropical ridge has been squashed. All right. And then forecast here, the European temperature anomalies on the left, showing the purple coloring. This is the core of the coldest temperatures across the Dakotas, Nebraska, Kansas. Hey, you in Oklahoma, hey, you got some more cold coming. And don't forget Texas. I'm not leaving you guys out in the Lone Star State up there in northern Texas. You are going to see some much below normal temperatures coming up here by 12 March. The green coloring going all the way to the East Coast, all the way down to Florida, all the way down to the Gulf Coast. Hey, we've seen all these plants bloom early. We've seen the flowers coming out. Unfortunately, we're not done with the colder temperatures yet. And then over here on the right is the forecast for 15 March temperature anomalies in degrees Celsius, showing again the purple coloring, the greatest anomalies below normal across the Dakotas, Nebraska, right in the central U.S., and then cold extending all the way to the East Coast, down to the Gulf Coast, all over the place. All right, so that's what we're looking at right now. These are the latest forecast charts. But it's March. You know what? It's not January anymore. And so I'm going to hit on a couple key points as to why March matters. Okay. All right. First of all, I'm just going to show you a general incoming solar radiation graphic. Now, this is for Virginia Beach, Virginia. All right. And it's just to use it as an example. This will vary depending on your latitude. So for example, if you live in Georgia, if you live in Florida, if you live in Texas, most likely these incoming solar radiation values are probably higher on your particular graphics. But I'm just showing you the trend here. Now, at the beginning of February for Virginia Beach, by the way, you kind of see the values here on the y-axis and solar radiation in watts per square meter. So initially basically in early February, the average incoming solar radiation range between 300 and about, maybe getting up closer to 500, just shy of that here in early February. So you notice that's pretty consistent, around 450 watts per square meter incoming solar radiation, right on through about the 12th of February. Now you notice this major drop off here, less than 150 watts per square meter on the 12th of February, but that was due to lower, thicker cloud cover and limited sunlight. But then look what happens after the 12th. Now it's really starting to spike up after the 12th of February. See this? Now we're starting to get values when we have a sunny day of incoming solar radiation easily in excess of 600 watts per square meter, but in some cases in excess of 650 watts per square meter. See this? See these peaks or these spikes? That tells me a couple things. That tells me that incoming solar radiation is increasing. But why is that? Well, if we were to look at this diagram here on the right, that was produced by Krishna Matthias from Press Graphic, you'll notice how, if you're this observer here on the ground, okay, and you're looking, that looks like you're looking to the southwest here, yeah. In January, actually, let's just say, okay, so the sun elevation angle is on the first day of each of these months. So we have January to June. Notice the path of the sun across the sky in the respective months. So this would be the 1st of January, and I'm not even sure what latitude this is. This is not necessarily Virginia Beach, by the way, here, these values here for the solar elevation. But on January, in this particular example, the sun is only 28 degrees above the horizon at solar noon. This is the highest point it reaches above the sky, or above the ground, is 28 degrees in January. Now, the sun is now, on February 1st, 34 degrees above the horizon. In March, it's 42 degrees. In April 1st, it's 55 degrees above the horizon in the sky. And in May, the solar elevation is now 66 degrees. In June, it's 73 degrees. So you see the gradual increase in the solar elevation, the angle, how high the sun is in the sky. See this? And that's very important to look at. So let's compare January in this example. It's only 28 degrees, the sun above the horizon at solar noon. That's the highest point the sun gets in the sky. And then look at March now. It's 42 degrees. So that's a 14 degree elevation increase in the sun's position in the sky between January and March. And that really matters because the higher the sun gets in the sky, the more intense that incoming solar radiation is going to be with the surface. And so looking at the graph here on the left again, notice how after the 12th of February, okay, the sun is continuing to get higher and higher in the sky in elevation, and as a result, incoming solar radiation is more concentrated, and therefore these values increase. And that's important as far as temperatures go, because with more increased incoming solar radiation, you've got greater heating per surface area, and that's going to result in more efficient heating of the surface, as well as modification of the cooler air masses over time. Now, another factor we have to take a look at. Now, I just took a snippet here of Virginia Beach again. The solar angle is increasing, as we just talked about in the previous slide. And here's an example for Virginia Beach. Let me just break this down real quick. So for tomorrow, the 2nd of March, at solar noon, which is about 12:16 local time, 12:16 p.m. local time, the sun is 46 degrees above the horizon. By the time we get down to 16 March, the sun is now 51.5 degrees above the horizon. So we've gained 5 degrees of solar elevation between the 2nd and the 16th. So a 2-week period. We've gained 5.5 degrees elevation for the sun. That's important. Additionally, these amounts of daylight hours is continually increasing. Specifically, if you look here on the 12th of March, we transition over to daylight saving time. So now we have an additional hour of daylight towards the end of the day. So now on the 12th of March for Virginia Beach, the sun doesn't set till after 7 p.m. Okay? As the solar elevation, the sun continues to climb higher and higher in the sky. And higher solar elevation or solar angle, the greater the heating per unit area. And now you're going to have that heating lasting longer because daylight sun doesn't set till after 7 in the evening. Additionally, we have to look at the average temperatures for a time period. We have to look at March 1st on this graphic for Virginia Beach. The average high is 55 degrees Fahrenheit. By the time we get over to the vernal equinox around March 21st, the average high has risen 5 degrees to 60. And by the end of March, the average high temperature for Virginia Beach, now this location is about 37.5 degrees north latitude. So if you go further south, these values are going to be higher, obviously. The further north you go, they're going to be a little bit lower. But by March 31st, our average temperature in Virginia Beach is 62 degrees Fahrenheit. So we've gained an average of 7 degrees Fahrenheit on our average highs for March. That's important, especially when you look at the temperature anomalies like we did. So let's say we had let's just say we had a 7 degree Fahrenheit below normal temperature anomaly. Well, that anomaly or the actual temperature is going to be different at the end of March. So if I'm 7 or 8 degrees cooler than normal at the end of March, when the average temperature is 62, average high, my temperatures are going to be pretty much in the lower 50s. Whereas if I get an 8 degree temperature anomaly at the beginning of March, now my high temperatures may only be in the upper 40s. So this matters. All right, so here are the final thoughts in tonight's video. We're definitely going to see a pattern change in March. It's on the way. After a very mild January and February, we talked about, just how crazy warm it's been this winter, specifically in January and February. I mean, January on the left and February on the right, and you're looking at the eastern U.S. pretty much without a winter this year. 5 to 10 degrees Fahrenheit mean above normal temperatures, okay? Next thing we're going to talk about is there's excellent ensemble agreement. The JEPs and the EPS, the last 2 to 3 days have been in lockstep with each other, all right? Showing that pattern change coming in. The subtropical ridge finally being suppressed and troughing in lower heights, pretty much influencing a good chunk of the United States. Additionally, we look at the Madden-Julian oscillation, the MJO, working its way into a stronger phase 8. And then also those other teleconnections, they all support the colder weather pattern in the east. Above normal temps will continue through the 8th of March before the transition to below normal temps. So we really won't see much change. So, it will get a little bit cooler, but it's not going to be, it's not going to be super noticeable, what I'm getting at. There will be a rebound in temps next Monday, the 6th, and Tuesday the 7th. It may hit the low 60s, for example, in the mid-Atlantic. Then after the 8th of March is really when I see the changes occurring per the ensemble models. Now, there will be chunks of colder air that are going to migrate from west to east from the main core of the coldest air in the central U.S. There will be little chunks of colder air that's going to break off and move towards the East Coast between 9 and 17 March. And right now, looking at the models, I believe the coldest period is going to occur from 12 to 17 March. That looks like the center point of the coldest temperatures, or the greatest below normal temperature anomalies. Additionally, and just hit this hard, but keep in mind that March below normal temperatures are not going to be the same as January below normal temperatures, as these average high temperatures continue to increase with each passing day. And here's another example here I put up here, but let's just say the average high of 14 March is 56 degrees Fahrenheit. And we looked at the temperature anomaly maps, okay? Let's go back to them. These temperature anomaly maps, right? Let's say these temperature anomaly maps are indicating a below normal temperature for that day on the order of 9 degrees Fahrenheit. All right, so on 14 March with an average temperature of 56 and a 9 degree Fahrenheit below normal anomaly that day, that would yield a high temperature of 47. All right, so this obviously would be much colder temperature in January. Let's say when you have average highs in the 40s at that point, and I take 8 or 9 degrees off that as an anomaly, now you're talking pretty cold weather. So it will be cooler, but it's not going to be anything, that we could have really maximized on back in January as far as cold, like freezing, shivering temperatures, right? So it won't be the same effect. The increasing sun angle or elevation in the sky, important. That yields that more direct incoming solar radiation that tends to modify these colder air masses a little bit more efficiently, a little bit more quickly. And you may notice this after sunset, the temperature may drop off pretty quickly, especially if you have a dry air mass where, temperatures might drop into the 30s overnight. But then by 11 a.m., your temperatures may have rebounded 15 degrees Fahrenheit and may already be like 50 degrees by 11 a.m. All right. So there's a larger range in the daily temperatures between morning and afternoons, specifically when you get drier Canadian air or continental polar air to come from Canada. You get that drier air mass in place behind departing cold fronts or storm systems. That dry air with lower dew points can really rapidly, more efficiently modify from the morning to the afternoon. And in order to offset the effects of this increasing sun elevation in the sky, the increasing solar radiation, the increasing daylight hours, you have to get stronger northerly winds and colder air advection to offset it. Getting northerly winds around 10 miles per hour this time of year is just not going to give you that effect. But if you get northerly winds, let's say at 25 to 30 miles per hour now, straight northerly winds, that will have an effect, and that will feel quite cold. And then finally, daylight saving time begins next weekend on Sunday the 12th of March. That is going to allow sunset to be pushed back, move the clocks forward an hour. That sunset's going to be past 7 p.m. at that point, right? Now, yes, it can still snow in March, but it becomes increasingly less likely due to the effects I've discussed, due to the increasing solar elevation, due to the increasing incoming the solar angle, the solar radiation, the increase in the daylight hours. It makes it very difficult. And I will say this, speaking from the mid-Atlantic standpoint, now up in New England, you may be able to get snow falling during daylight hours in March. But the one big thing is down here in the mid-Atlantic, back in 2018, we had that sudden stratospheric warming event similar to this year. And in March, it actually snowed here in Hampton Roads, Virginia, but it occurred at night. It actually stuck to the ground into the roads a little bit, believe it or not, but it was occurring at night. So chances of getting snow during the day at the mid-Atlantic area in March is minimal. Getting snow at night with the right timing is still possible. All right. And another thing to mention during the day, even on cloudy days in March, you're getting to the point now where the solar radiation is becoming stronger and stronger with each passing day. So a cloudy, let's say a thick, low overcast of stratus clouds back in January may have been much more effective in keeping the temperature lower because you have less radiation that is basically leaking through the clouds to the ground. But now in March, that radiation is getting stronger. So even on cloudy days, they might be cool, but they're not going to be cold like they were back in January. Now, big storms can and do occur in March. I'm watching the 10 to 15 March time period closely for a cyclone development, storm development. Another common theme in March that you typically see is wind. Because, you're starting to get into the transition time of year where winter is still trying to hang on, but yet spring temperatures are trying to move north. And so you're getting a major battleground going on with strong, fairly strong cold frontal passages, very significant thermal contrast on each side of fronts. And then you get strong jet stream winds this time of year in March. And that typically results in a lot of severe weather, specifically in southeastern U.S. Back to the southern plain states could get very strong to severe thunderstorms and tornadic. You can get turning of the winds with height. You got a lot of vertical wind shear, and you got a lot of lift from these dynamic systems. Instability is there when you just get a little bit of sun to come out and heat the surface, and then you get some moisture coming in from the Gulf of Mexico. That's a recipe where you can get some severe weather outbreaks in March. You get a lot of wind. You get a lot of major temperature and pressure changes, barometric pressure changes. If you look at your barometer, you're probably going to notice a wide swing of pressure from day to day. Unfortunately, if you have like some kind of arthritis or you get headaches frequently, this isn't a good time for you because of those, if you're sensitive to pressure changes like that. But generally, you get large temperature and pressure changes that yields periods of stronger winds, and they get quite gusty at times. And then finally, with stronger winds at the surface and aloft, and you get greater thermal contrast again, or temperature changes over short distances, that can result in significant storm systems in March, and they can yield both tornadoes in the warm sector and heavy snow and even blizzard conditions in the colder sector of the cyclone or the storm. So, March is a very dynamic time of the year. It's a transitional month. As winter tries to hang on desperately, the milder temperatures are now starting to push a little further north. And so you're getting a lot of battleground areas. And you have just a lot of severe weather potential in the month of March. All right, that wraps things up. We're going to keep an eye on that 10 to 15 March time period for potential storm development, by the way. All right, that wraps things up tonight on the video. I hope you enjoyed it. We discussed quite a bit. And hopefully, you really got some education out of this video. I don't like just to sit here and break these, just basically talk to these charts like I'm talking to everybody who's watching this like they know the weather. Not everybody knows the weather to this degree, this in-depth. So I like to really take my time and explain these charts to you so you can somewhat understand what I'm talking about in each of these graphics I show. And hopefully you get a little education out of it and learn. But in general, things are looking colder as we head into March. The pattern change is there on the ensembles. The operational models, I was looking at the GFS earlier today, and, GFS to me just, I don't know. I don't know if I necessarily like it. I think operational models are a little bit more chaotic as compared to ensembles. But in general, this is what we're looking at. We've got this major stratospheric warming event that's taking place. We're going to start seeing some of those effects. The MJO heading to a strong phase 8. The teleconnections all working together in the same direction for a change for once this winter, or from as compared to winter. We're actually in meteorological spring now, so I got to watch my language here. But anyway, that's all I got for right now, everybody. I hope you enjoyed the video presentation. And until next time, take care and God bless everyone.